So for those of you who checked my latest Q&A video all about the gateways, I did promise that I'm gonna do a more in-depth session to explore the concepts of primary, secondary, super gateway, partner gateway, SaaS gateway. But then I realized that before we do that, we should explore another great value that VeloCloud brings to the table, and that is called dynamic multipath optimization, or DMPO. And the reason for that is, without truly understanding what DMPO is and how it helps you, you might struggle to understand the value of bringing all the gateways in the equation to start with. I mean, it's great that any VeloCloud solution uses gateways for the control plane, and that's abstracted from the end users. But without the MPO, there's not really any reason to use them to forward any data to it. So the MPO's main focus is to deliver assured application performance across any type of transport. And if you think about it, if you're using private links in that world, you can use DHCP markings to prioritize the right traffic. However, how do you actually do that on top of a public infrastructure? You can't. Nobody's guarantee anything. So we're with DMPO and SD-WAN in general, we go away from that, right? So we're looking at new quality of service mechanisms that understand the applications beyond the usual layer 2 to layer 4 characteristics and prioritize them based on the health of the underlying infrastructure. So let's hop on the whiteboard and explore things further.
So let's whiteboard an example. I picked up quite an easy and straightforward one in which I chose two edges on either side. I connected them with a public circuit and a private one. But obviously the solution is way more flexible than that. So you can bring way more than two circuits at each location. You can use a mixture of public wired, public wireless, private links. It doesn't really matter. The beauty of DMPO is because it's inherently an overlay technology, it actually allows you to abstract the underlay and treat everything the same. So the first thing that the edge will automatically try to do is to create these overlay links. And it does that on all the available paths. Now, the important thing to note is that here we are using what's called VCMP, which is VeloCloud multipath protocol to establish these tunnels. That's something proprietary. It allows us to insert sequence numbers and timestamps and start monitoring the underlying links. But also, most importantly, everything else is encrypted via IPsec. So we're talking about next generation encryption and authentication methods such as IPv1, AS256, and SHA-256 to make sure that obviously everything is transported securely. And all this is actually encapsulated in UDP, so you'll find it over port 2426. So let's get this out of the way and start describing a few of the cool functionalities you will get now you have the tunnels established. So the first thing to note is the continuous link monitoring. So the first time an edge boots, what it does is going to go through a series of bandwidth tests between itself, and its primary gateway, and also between itself and all the other peers inside the Cloud VPN. Um, Now, what this allows us to do is to go beyond the usual static definition of the upstream and downstream bandwidth, because the reality of most circuits out there is that they never tend to perform up to their maximum specifications. And if we set manually a value that's actually higher than the real speed, what will end up happening is that the edge will flood way more than the receiver can handle. So by running initial and also continuous bandwidth tests, we just make sure that the scheduler um, queues the packets instead of flooding them so they get dropped. Secondly, we will monitor the quality of service. So I mentioned before that the VCMP header has sequence numbers and timestamps, and that actually allows the edges to understand if there is significant delay, jitter, or packet loss in each of the lines. We use the normal traffic that flows, but in case the tunnel is up but nobody's transmitting, we will use the heartbeats that flow about every 100 milliseconds. All this monitoring actually allows us to then take an informed decision when we route packets between each location. First of all, we need to identify the application. So we have a dynamic way of doing this with the dynamic application recognition engine. And we use things such as layer 2 to layer 7 attributes, an application database, and also heuristic-based mathematics. Now, once we understand the application, we are then able to steer per packet. And this is very important because most technologies out there steer per flow. So in case one of the link degrades, you will have to move everything on the second link. However, VeloCloud is one of the few technologies out there that does this per packet. This is critical because now we can steer packets very fast. We have sub-second reconvergence at failure. And also, it allows us to fully utilize the sum of the entire bandwidth. So if you're the only one in the office and you're downloading a large file, previously you were limited to the bandwidth of the link the flow was chosen to go on. Now you can utilize all the links at the same time. Um, Obviously, I need to mention that the receiving end here will be able to put the packets in sequence. So there's no issue with out of sync packets. Now, what happens if by accident all the links are actually going through a brownout state, right? So they're not performing well, or you are in a site that only has the one link and that starts to go bad. This is where, on a per application basis, rather than for the whole traffic, we start applying remediation techniques. And although we don't use WAN optimization techniques such as compression and deduplication, because again, it's bring your own bandwidth. Bandwidth is not really a concern. We are enabling things such as duplicate packets for UDP real-time applications, just to give them that extra chance of making it across. Don't worry, if the receiver actually receives the duplicate packets, it will discard one and just forward the other. And also on-demand jitter buffer. Now for TCP transactional apps, we are doing error correction. So in case some of the packets were missing, the receiving edge will send a negative acknowledgement, thus protecting the actual applications from triggering these retransmits, thus making the transmission faster. Now, last but not least, we also have the quality of service element. So this is where you can set business policies, identify what apps are important for you and which ones are not, and set up guaranteed bandwidth or perhaps rate limit them. Although the QS should be a class in itself, and I'll definitely do a more in-depth video later on this, the most important thing to note is that we have 9 classes that are defined by 3 priority and 3 service levels. So we have high, normal, and low priority, and real-time, transactional, and bulk service levels. So what happens that each class has its own weight. That weight dictates the percentage of guaranteed bandwidth in case of contention, and in case the link is actually not congested, we will allow the classes to burst. Again, the scheduler is responsible for the fairness amongst peers and fairness between flows in the same class. Now, before I go in the orchestrator and show you a few things, I also want to discuss the link steering. So in this example, obviously I'm with DMPO, I am monitoring the underlying infrastructure. And if I set this link steering to auto, it will mean that I'll be able to utilize the whole extent of the technologies under DMPO to assure the application performance, no matter if those are the remediation techniques, the packet balancing techniques, it doesn't matter. We actually do recommend for the critical traffic to allow it to use the auto as much as possible. Now, if you want to pin traffic on certain routes, you can choose to do so. Obviously, that will impede DMPO to show some of the benefits. However, there are 3 options here. First of all, it's the mandatory option. That's probably perfect for traffic that you're happy, for example, to cross the inexpensive broadband line. But in case that fails, you don't really want it to cross the MPLS. You can have available, in which you say, hey, as long as the internet overlay is available, use that. If the whole thing goes down, use the MPLS link. And you also have the preferred version. So this basically says, use this particular WAN link or this particular transport group. But in case that overlay degrades, so you have to obviously specify in percentage what that degradation means, choose the other link. So now let's quickly hop in the orchestrator and I'll show you how to set everything up. So I just quickly hopped into my home/test network here. You'll see that I have my 510 Edge with 2 active links at the moment, a wired broadband and also a 4G backup. I have a new edge that I placed in AWS for testing purposes. So in our case, we can use it as an example of a hub or a data center. So let me hop in the configure edges tab here. You'll see that the device itself has Cloud VPN enabled. So this is inherited from the profile or the template that I apply to it. You'll see that the only thing that the Cloud VPN does is bridge my edge to the edge in AWS. And this automatically builds the overlay tunnels and abstracts the fact that I'm using a wired and also a wireless link. On the bottom here, I can actually configure my WAN overlays. You'll see one of them is marked as public wired. One of them is marked by public wireless. I actually attached the interfaces to it. And the reason I'm defining this is because then inside my business policies, I can just define my expected behavior for particular traffics. Now, by default, the WAN ports are actually marked as auto detect overlay. However, if you are using private circuits and you still want to create an overlay over, let's say, that MPLS link, the recommendation is to mark it as user defined. If obviously there's nothing there and that link is not an upstream WAN link, you can just kill off the overlay function altogether. Now let's go inside the business policy and see how we can do this link steering. So just hopping into my home profile or template. You'll see again, the box comes with about 25 or so predefined business policies. Makes your life easier if you're an IT admin and you're just trying to roll this as fast as possible. And if I click in any of these applications, I see I can match traffic based on source, destination, whatever that's the IP, the host name, etc. You can use the application recognition engine here. Again, more than 3,000 applications. And if I manage to type right, you'll see that we differentiate quite well between multiple functions of the same app. And then once you define that, you set a particular action. Now, I wanted to note here that you can leave this traffic on auto. So this is where my home edge for that particular traffic will use kind of any given link if it's good enough to support the particular application, whether that's real-time, transactional, or bulk. In case no link is good, it will start triggering remediation techniques, etc. If I don't want to do that and I want to be a bit more specific, this is where I can use the transport groups that we defined earlier. Because in my case, it's quite a simple setup, but for example, I can have 2 broadband links plus a private MPLS circuit. The 2 broadband links can all be viewed as public wired here. So I can just say, you know what, this is my guest traffic. I'm happy for it to follow the internet. However, on failure, I wanted to drop it altogether. I don't want to use my expensive MPLS line. Obviously from here, I can specify either available. So that means that if public wired goes down altogether, use the rest of the links, or preferred, in which I now have to specify the level of loss that has to occur on that link before I start shifting things on my public wireless in this example. Now, the benefits we discussed about overlays apply to the edges communicating between themselves, so between the branch and the hub, or between the branches if you have applied the dynamic VPN between them. But it also applies between the edges and the gateways, if you choose to use the gateways part of the data path. So in the next session, when we're gonna dive deeper into the gateways, please remember the DMPO and the benefits, because again, without them, using a gateway will be quite useless.